Good morning. Thank you very much. I teach at Olin College, which is a new engineering school just outside of Boston. And I'm working on a book series that's about using Python to teach data science and related topics. And that's part of what today is about, is using computational statistics in Python, in particular age-period-cohort analysis, which is a really useful technique that a lot of people might not have seen. And the case study I'm going to apply it to is generational change in support for gun control. So many of you probably know that in February of last year, there was a mass shooting at a high school in Parkland, Florida. And afterward, there was a lot of discussion of gun control, and the media coverage often implied that support for gun control has been increasing, and especially among young people. This letter to The Economist spells out what I think a lot of people believe, which is that young people raised with active shooter drills and seeing images of mass shootings would not support the National Rifle Association. They would be in favor of gun control. And one of the survivors appealed to the idea of generational replacement, that if older people don't support gun control, as they die, they'll be replaced by younger people who do. It turns out that neither of those things is true. Support for gun control in the US has been going down consistently for about 20 years, and especially among young people, they are the least likely generation to support gun control. When I say this, it takes a little while for people to untangle the double negative of not supporting gun control. So let me say that one more time. If you control for demographics, somebody born in the 1990s is about 8 percentage points less likely to support gun control than someone born in the 1960s. So that comes from data that I'll show you from 3 sources: the General Social Survey, the Freshman Survey, and data from the Pew Research Center. I'll start with the GSS. This is a large-scale survey of a representative sample of United States residents. It's run from 1972 to 2016, and they've consistently asked this same question: would you favor or oppose a law which would require a person to obtain a police permit before he or she could buy a gun? This is what that looks like over time. This is the percentage of people who would favor that gun control measure. It was in the low 70% range. It rose until about the year 2000, and it's been falling consistently since that time, almost 20 years. Now, they ask the question in a particular way. You might think other surveys with different questions might be different. The Freshman Survey is a very large-scale survey of incoming college students in the US, more than 100,000 students each year. They asked a somewhat different question from 1989 to 2013. The federal government should do more to control the sale of handguns. The students had a choice of agree strongly or disagree. So I'm going to report the percentage who agree strongly or somewhat. The most recent data in 2016, they asked a slightly different question. The federal government should have stricter gun control laws, same scale of responses. Here's what that looks like. The blue line is that GSS data again. The orange line is the Freshman Survey, incoming college students. That triangle there is discontinuous because that's the different wording of the question. But the trend overall is the same. It's been consistently declining since about 1990. College students, of course, are not a representative sample of the population. So we can go to the Pew data. This again is representative of the US resident population. They asked, what do you think is more important, to protect the right of Americans to own guns or to control gun ownership? They asked that from 1993 to 2017. That green line shows the data from Pew Research. It's lower in absolute terms because it's a somewhat different question. They really framed that question in a different way. But the overall trend, declining since 1990. is the same. So one thing to think about, the Parkland survivors that I talked about at the beginning are not in this data set yet. These are surveys of adults. People who are still in high school might not show up in that data yet. But I want to zoom in the freshman college survey. That data point is the graduating class that graduated from high school in 2013. 64% of them supported this gun control measure, and that was down 20 points from the highest response, which was in 1998. And thinking about what their experience was, they were 3 when the Columbine mass shooting was in the news, so they probably weren't aware of that. But then when they were 10, 11, 12, and 13, there were nationally reported mass shootings in schools. And during their senior year of high school, there were 2 nationally reported shootings and the Sandy Hook Elementary School shooting. Sandy Hook was in December of their senior year, and then 9 months later, when they went to college, they reported the lowest level of support for gun control in the history of the survey. So there's not a lot of reason to think that school shootings increase support for gun control. Now, so far I'm just looking at time series data, so this is a limited view. We can get more insight from age-period-cohort analysis. Because of the design of the GSS, where they asked the same question to a representative sample over a long period of time, we can distinguish between a period, cohort, or age effect. And I'll just explain what those are. So a period effect is something in the world that affects all demographic groups at the same time, not necessarily by the same amount. An example of that would be media coverage of mass shootings might increase or decrease support. A cohort effect is related to when you were born and what your life experience is. So for example, if you had duck and cover drills when you were in school, you might be more worried about nuclear war. And if you have active shooter drills, that might affect what you are and are not worried about. And then the third possibility is an age effect, which is your opinions might change consistently as you age. So, for example, maybe your attitude about recreational drugs is different when you're in college than when you have children. I don't actually know that that's true, but that would be an example of an age effect. In general, it's not easy to disentangle these things. If you have a single snapshot in time, you can't tell the difference between a cohort effect and an age effect. But with the GSS, we can. One way to do that is to divide people into groups and then plot support for gun control over time. So if there's a period effect, we should see all the groups going up and down at the same time, because there's something in the world that influences everybody. This is the GSS data again. I've broken it up into birth cohort by decade. So this is people who were born in the 1940s, born in the 1950s, up to 1990s. Those are the youngest people we have data for. And you can see a consistent pattern. All of the groups were increasing support for gun control until about 2000, consistently decreasing since. So that's evidence of a period effect. We can see the same thing if we divide people up by at what age they were surveyed. So people who were surveyed when they were in their teens, that's the red line. So people up to people who were surveyed when they were in their 80s. And again, we see evidence of a period effect, which is that all groups move together because of something happening in the world. So just from a visualization of the data, we see some evidence for a period effect. We can also look for the possibility of a cohort effect. And a simple check is to just plot as a function of birth year. When were you born and do you support gun control? With the GSS data and the freshman survey, we can get that. So this note is year of birth on the x-axis, not the year that the survey was conducted. So people who were born in the 40s had a relatively low level of support. The highest is for people who were born in the 60s and 70s. And then the generations born in the 80s and 90s have been declining sharply in both the GSS and the SERP datasets. So strong evidence for a period effect, probably a cohort effect. There are also some visual tests for an age effect, and I'm going to point you, I've got a Jupyter notebook where all of this analysis is. So for now, I'm just going to wave my hands and say, there's no age effect. What that means, though, is having picked 2 out of 3, we can move on and do some regression analysis. And I say that because if you put age, period, and cohort into a regression analysis, bad things happen, because the year you are born plus your age is the year that you were surveyed. So you have a linear relationship between your variables. Regression doesn't like that. But the analysis now tells us which 2 variables to put in, and now we can control for all the other demographic variables. So I'm going to put in a cubic model of year in order to capture that up and down period effect. I'm putting in the decade of birth to capture the cohort effect. And then the demographics, I have race, sex, education, income, political alignment, and urban, suburban, or rural residents. We can run logistic regression to try to use all of those variables to predict support for gun control. The results from that, if you're familiar with logistic regression, we get log odds ratios, which are not the easiest things to interpret. So I have a suggestion for interpreting logistic regression, which is if you start with a base case and then turn on one variable at a time, you can see independently what each variable does relative to your base case. So I'm going to pick my next door neighbor, white male, born in the 1960s, using the most recent data from 2016, suburban, not college educated, income that's neither particularly high or particularly low, and middle of the road political affiliation. So that hypothetical person would have a 64% chance of supporting gun control, at least the way the General Social Survey asked that question. And now we can flip one variable at a time and see what effect it has. And this only works one variable at a time. It doesn't work with combinations of variables, but it can be a nice way to just get an intuition for what effect each variable has. So these are some of the variables that indicate more likely support for gun control. In particular, women are substantially more likely to support gun control than men. So starting from my base case at 64%, if that same person, or identical demographics, but female, would have been about 15 percentage points more likely to give a positive response to this question. Someone who is African American or another race is also more likely to support gun control. Someone with liberal political affiliation, not surprisingly more likely. And also, if you go back in time, 10, 20, or 30 years, you are more likely to support gun control. Number of factors that have either a small effect or possibly no effect: college education, income, and other generations around the 1960s. So people born in the 20s, 30s, 40s, and 50s are statistically about the same as people born in the 1960s. Variables that are associated with lower level of support for gun control: if you don't live in the suburbs, if you are either urban or rural, if you have conservative political affiliation, or if you are young, if you are born in the 1980s or 90s. So pulling out that cohort effect, controlling for the period effect, and controlling for demographics, if you were born in the 1970s, 80s, or 90s, you are about 3, 5, or 8 percentage points less likely to support gun control compared to someone in the 1960s. Similarly, we can pull out the period effect, so controlling for demographics and cohort. This quantifies the decline over the last 20 years, has been 14 to 15 percentage points. So that measures the period effect, controlling for everything else. Okay, those are the primary results. I want to talk a little bit about the methodology that I used, and then I also want to report a new data set. So everything that I've told you so far is up through 2016. The General Social Survey released new data in April of this year, so I've had a chance to run the analysis again with the most recent survey data. The framework I used here is a computational framework that I've presented at SciPy, so some of you might have come to my tutorial and learned about this. The idea is that we are making estimates of things like percentages in the population and regression coefficients. For each of those estimates, we want confidence intervals that quantify our uncertainty about those estimates. The GSS makes this a little bit difficult in one way, which is that they use stratified sampling. So I said it was a representative sample of the US, but it's not equally representative. They deliberately oversample certain groups to make sure that they'll have enough data for each group to make valid inference. But that means that every respondent has a sampling weight attached to them that we have to take into account in the analysis. And there's also missing data, which is inevitable in this kind of survey data. They don't ask everybody the same question every year, and not everybody responds to every question. So I used a lot of bootstrap resampling, which is the idea that you take the data that you have and you simulate an alternate universe where you could have selected a different sample. And you do that by drawing with replacement from the sample that you actually got. So that's a bootstrap resample. By attaching weights to each respondent, you can correct for the oversampling. So you can take their oversampled data and simulate a straight representative sample of the population. With missing data, you can take all of the valid data for that response and make a distribution out of that and draw random samples from the valid data in order to fill in the missing data. And of course, that adds randomness to the analysis, but that randomness is helping you to quantify how much variability in your results is due to missing data and how much of it is due to the sampling process. So if you do those steps 100 times, or 101, you can run your analysis, and you can run an arbitrarily complicated analysis pipeline and collect the results. And then to summarize them, you can pull out the median or a 90th confidence interval, 90% confidence interval, whatever summary statistics you want to pull out. So this generalizes to any kind of analysis, and you can summarize it in whatever way is appropriate. And as I said, it gives you a way to quantify the uncertainty in your estimate due to both random sampling and missing data. The nice thing about this is that it's conceptually easy, and it generalizes to arbitrary pipelines. You have to throw some computation at it, but it's not an unreasonable amount. For this data set, kind of a medium-sized data set, 40,000 respondents, a few hundred variables, it takes less than a minute to run this whole analysis, so not a major practical issue. If you want to see all of the details, they are in this GitHub repository. I'll also give you the link to this slide so you can get to all of this. If you'd like to learn more about computational stats and this approach to doing analysis, this is in my book, which is called Think Stats. It's available from O'Reilly, but you can also download it free from ThinkStats.com, ThinkStats2, second edition.com. So to summarize, there's little evidence that mass shootings increase support for gun control measures. And generational replacement in this case is working against gun control. Older people who support gun control will die and be replaced by young people who don't. However, as I said, we get new data every 2 years from the GSS. So this includes the youngest adults who just turned 18 and 19. Unfortunately, we won't get new data from the freshman survey. They've dropped the question from their panel, so no new data. This is everything up until 2016, and this is the new data, including the new 2018 data point. So look carefully at the right-hand side of that graph. This is 2016, consistent decline since about the year 2000. With the newest data point, there is a slight uptick there. From the error bounds, you can estimate that that's not statistically significant, so we shouldn't make too much of it yet, but it is the first uptick in 20 years, so maybe this time is different. Let me say thank you for all of the software that I used for this analysis. Many of the people in the room have contributed to the tools that I used. Also, thank you to all of the groups that made this data freely available. If you are interested in these topics and you want to do any kind of similar analysis, you can download all of this data. It's just great that groups like this make that data available. And last, I want to say thank you to SciPy for the chance to talk, and to you for coming to my talk. Thank you.
We have time for questions, so there are questions straight away.
There's a link there to these slides if you want to grab them. And there are 5 different ways to get in touch with me. On my blog, I just posted these slides and also my tutorials and my talk from the teen track. So if you want to look at any of that, that's all available now.
Yeah, looking at your graph for the historic support for the gun control, immediately my eyes went on the year 2000, like you mentioned. And what jumped to my mind is the 9/11 incidents and global security psych for people. Since then, we have also a series of minor, but maybe significant to the psych of people, some local terrorism, and other than schools. Schools is it's one issue, but we have other things. We have the Boston attack, we have in California, we have in Florida, and and the news full of bad news about. So I think it would be nice to do a regression considering those facts as well.
Right, it's a good question. You're asking, when you see a trend like this that turns around at a point in time, it's natural to ask, is that the terrorist attacks of 2001? Is it the other, you mentioned other global terrorism since then. You mentioned other possible hypotheses. Statistically, it's very hard to tease those things apart. Some other things that have been happening since the 1990s, the rates of crime in the United States have been going down consistently over this time. But in general, it's very difficult when you look at a period effect like this to identify particular causes. The National Rifle Association really ramped up their political activities in the late 80s and started spending quite a lot of money. So that could certainly be one of the contributing factors as well.
Hi. This was an awesome talk, and also I went to your computational statistics thing in 2015, and it was great, so thank you. I have a question about like people who are particularly incentivized to answer questions, right? Because you said that there's like a lot of missing data. How do you control for like people who are like, who want to say like, no, I don't support it, or yes, I do, or any particular way? Because you're interacting with humans who may or may not be honest, or they're particularly motivated.
Yeah, so you're asking about the incentives when people are asked questions like this. There's a phenomenon of social desirability bias, which is that they often want to give an answer that makes them feel good about themselves or appear good to others. And that's always an issue with survey data. One of the advantages of asking the same question consistently over time is that the absolute level might be influenced by those effects. But in general, the changes will reveal that something is changing. Now, what's changing might be the opinions of the person answering the question, but it also might be their perception of social desirability. But in some sense, both of those are relevant to this analysis. It's, things are changing in the world about how people think, but also how they respond to these kinds of questions.
Question about your dealing with missing values. So you sampled the bootstrap, you applied the bootstrap. Suppose bootstrap picks up an entry with missing values. What was your strategy of dealing with that?
I'm not sure I heard everything, but I think you were asking, well, what was my strategy for replacing missing values?
Not replacing. So your bootstrap picks up a row with missing values in it.
Right.
So what did you do in your analysis?
Exactly right. So I do a bootstrap. Now I have rows that have missing values. So I'll take that column that has missing values in it, extract all the valid data, and then draw a random sample from it to fill that missing value. And because it's random, it's not associated with the respondent that I just attached it to, but that randomness is in some sense allowing me to measure how much information have I lost because of missing data. I'm assuming that the features are independent when I do that, and it's a deliberately bad assumption in order to, in some sense, conservatively estimate how much variability is due to missing data. And you can see, the error bounds that I generated are small-ish, 2 or 3 percentage points.
And maybe the last part of the question, did you try to remove the fractional bootstrap instead of doing
I didn't. I just did a straight resampling with replacement. And just one other thought on the missing data. One other option would be to fit a model that uses demographic information to predict the missing data and then fill it in with the predictions from that model.
Hi, over here on the left. So I thought this was a really interesting talk, and if I recall your methods correctly, you defined favoring gun control as either strongly agree or agree somewhat. In your experience sort of looking at the survey data over the years, could you talk about sort of the strength of the opinion? Has sort of the surveyors' ambivalence increased over the years, or is the strength of the opinion being more sort of polarized?
That's a great question. So you noticed at least one of the surveys asked strongly agree, somewhat disagree, and strongly disagree. And I discretized it to just 2 categories, and I lumped together strongly and somewhat. And your question is whether the strength of opinions might be changing over time. Maybe it's becoming more polarized and people are moving away from the middle toward the more extreme responses, or the other way around. I have not looked at that. I think it's a great question. This is one of the reasons that I make the data and the notebook available, which is that you could grab my code and have it up and running in about 5 minutes, and you could answer that question. And if you do, please report back.
All right, that's it for questions for now. Let's thank Alan again, please.
Thank you all.